Alright, so we're going to add and subtract matrices, and there are, a few rules for adding and subtracting matrices. One big rule is they've got to be the same, two matrices of the same dimension. So I've just made up a little problem here. We've got, let's say we have the freshmen, boys and girls, and we're looking at some grades, A, B, C, D, and F. Somebody from first period said, why did you leave out E? 9, 7, 6, 3, 2. Oops, 2, 2, 1, 0. There we go. So there are the freshmen, boys and girls, and some grades. And here are the sophomores, boys and girls. The same kind of thing. A, B, C, D, F. The girls, of course, always getting more A's than the boys. Alright, so first off, what are the dimensions of, let's say, the freshman matrix? What's the dimension? It is a 5 rows by 2 columns. 5 by 2. Gotta get that straight, because when we start doing them in our calculator, you'll have to tell the dimensions, and then the calculator will do so much of the work for you. So if these two matrices have the same dimensions, we could add them. And I would probably call this, I'll call this one the F matrix and this one the S matrix. So I'm going to add F plus S. The resulting matrix is also going to be a 5 by 2 matrix. And in row 1, column 1, it's going to be the sum of row 1, column 1 of the F plus row 1, column 1 of the S, or 10 plus 6. 16. And that'll still be boys, and that'll still be girls, and this will still be A's, B's, C's, D's, F's. And next to the 16 will be 12 plus 15. 27. And on the next row, row 2, I'll do the 9 plus the 10, the 7 plus the 2, and get 19 and 9. And for the C row, I'll do the 6 plus the 3, and the 3 plus the 7 to get 9 and 10. For the D row, I'll go the 2 plus the 4, the 2 plus the 5, and get 6 and 7. And for the F row, I'll have the 1 plus the 3, and the 0 plus the 1. And my resulting matrix is the number of A's, B's, C's, D's, and F's for all freshman and sophomore boys, or all freshman and sophomore girls. Yeah, so I've just combined those two matrices. You can add them or subtract them. Okay. Oops. Let me try to go a little further down here. A couple of definitions here. An identity matrix is going to be, we'll call this one I, and let's see if you can figure it out. Let's say I have a matrix 1, 2, 3, 4, 5, 6. And what are the dimensions of that? 3 by 2. And if I add the identity matrix to this first matrix, when I add the identity, I want the original matrix back. 1, 2, 3, 4, 5, 6. So what's the identity matrix? 0. So how I will actually write this, come on, new page. Yeah, it needs to be of the same dimensions. So this identity matrix needs to be 3 by 2, 0, 0, 0, 0, 0, 0. Okay. And we'll do an inverse matrix. Somehow that word doesn't sound quite right to me for what you call this. But yeah, the inverse matrix. God, somewhere I am. Something seems not quite right to me. But anyway. So if the additive inverse matrix, that's what it's called, not just the inverse matrix, additive inverse matrix. All right, so if I add another matrix to some matrix and get the identity matrix, this one will be the additive inverse matrix. Okay, so what do you think the additive inverse of negative 1, 3, 7, 2, 8, negative 4 would be? 1, negative 3, negative 7, negative 2, negative 8, positive 4. So that would be the additive inverse. Okay. So then let's do some kind of simple equation solving. So we'll do matrix equation solving. Yes. Yeah. So I'm going to have some matrix X. And when I add it to the matrix 3, 2, negative 1, 0, 7, 5, 8, negative 1, negative 2, I'm going to get the matrix 4, 17, 3, negative 8, 0, negative 1, 2, 1, negative 2. So let's see if we can figure out what matrix X is. Well, I'll actually just I'm going to solve for this matrix X. So I'm solving an equation where the variable is matrix. So if I subtract this matrix 3, 2, negative 1, 0, 7, 5, 8, negative 1, negative 2 from both sides of this equation, that should give me what matrix X is. Okay, so I have the identity matrix on the left side of my equal sign. And on the right side of my equal sign, I got 4 minus 3 is 1. 17 minus 2 is 15. 3 minus negative 1 is 4. Negative 8 minus 0 is negative 8. 0 minus 7 is negative 7. Negative 1 minus 5 is negative 6. 2 minus 8, negative 6. 1 minus negative 1 is 2. And negative 2 minus negative 2 is 0. So matrix X is 1, 15, 4, negative 8, negative 7, negative 6, negative 6, 2, 0. So we can solve an equation for a whole matrix, or within the matrix we can have variables. You ready? Okay. Last example. Let's say I have the matrix that's 3x and a 4 in it. What are the